Welcome to Cycle 1 of Module 5, Scientific Investigations. So we're going to be looking at what initiates a scientific investigation and therefore what then happens after that process. We're going to be looking at specifically the work of Marshall and Warren and peptic ulcers, von Helmont and plant growth, and Spencer and the microwaves. We're going to be looking at how the scientific method is not necessarily traditional and how many follow something that is not a linear model. Okay, and we're going to be looking at what scientists, when they're undertaking investigations, what are they looking for when they do those. So we're going to investigate mainly the work of these researchers that led to some new discoveries, mainly looking at those three that we've mentioned there previously, with a few practical activities in the classroom as well. So, scientific investigations are deliberate or organized processes to try and answer a scientific question, which sometimes we would refer to as a scientific question, okay, based on observations that occur. So sometimes it's about finding relationships or patterns in phenomena that observations have been made about. Sometimes testing the conclusion of previous investigations. So I guess validating that scientist's work. And sometimes it's utilizing scientific knowledge that we've been able to create over time to make more accurate predictions over time by developing and using new technologies. So, always about either trying to improve or increase our understanding. And we're going to be talking about why it would not necessarily be a linear process. So, I guess the linear process that we may have done in the junior school, and sometimes we still look at this process, I guess, because we're working on investigations in a silo. But we kind of follow this linear process. So we're always looking at how we go from observations to then questions, making hypotheses, predicting, testing those, and then either falsifying or, I guess, validating those hypotheses. But really, it's more like this big diagram over here, more of a dynamic process where scientists are not necessarily bound by a structure, and we can move back and forth between these different parts. So, kind of, I guess, moving back and forth between these depending on what scientists are actually doing. And it's because scientists, they become inspired by that curiosity, and one thing would lead to researching another thing. So, constantly moving back between that gathering information, but also validating what we see, making new observations. So, not necessarily bound by a structure. It's quite complex. And I guess the most important part is no matter what process we use, it needs to be documented. So, therefore, that somebody else can then validate or improve that work, just like we talked about previously. So, the first scientists we're going to look at and the discovery that they made is Marshall and Warren and their work with peptic ulcers. So, peptic ulcers are, in fact, a break in the tissue of the GI tract, I guess, which causes a lot of discomfort and pain. So, if you had an ulcer, you'd definitely know it. So, the original assumption that peptic ulcers were caused by spicy foods, stress, smoking, and heavy drinking, all of which would create that buildup of acid in the stomach, which would cause that GI tract to kind of break down. But in fact, biopsies from patients led to discoveries of Helicobacter pylori, which is in fact a microorganism, and by extracting those from those patients in those biopsies, then incubating those cultures, the growth occurred after 5 days. So I guess it required that little bit more patience. So 5 days is quite long to see growth, and it wasn't, I guess, almost by mistake that kind of took those 5 days before they checked it. And in fact, Marshall did what is not common and I guess kind of out of the ordinary. And it's mainly based on the fact that we don't test on humans. But in fact, infected himself with that tissue culture. And this, in fact, caused an ulcer. But by taking the antibiotics, the ulcer was cured. So he kind of tested on himself to help prove what he thought. And in fact, they did win the Nobel Prize. And interestingly enough, Marshall is also Australian. So I guess something really close to home about that never giving up, but also, yeah, diverting from that linear method by testing on himself was one of those strange things that happened in this investigation. We then have von Helmont and his work on plant growth. So the original idea was that plants grew from seeds and ate the soil. So eventually, over time, the soil would have lost mass, but in fact, the loss was due to the elements in the soil. So he found it difficult originally to establish that relationship between the loss of the mass but he knew that he had added water to that plant over time, and in fact, the plant had grown. So we can see here that the willow tree itself started at 2.3 kilos with that dry soil of 90.9 kilos. After 5 years, just giving it water, the plant grew 77, but the soil, in fact, weighed the same. So he's valid. His experiment was not considered valid because he never kind of established the link between the variables, and he only experimented on one plant. And originally he'd made the wrong conclusion. But in fact, his work allowed other people to build on it. And Hales, in fact, discussed the idea of gas exchange through transpiration, which was something that they hadn't necessarily quite thought of. And then we have Percy Spencer and microwaves. So microwave ovens, they directly interact with the water molecules in food, so that there's less energy lost throughout the process. And it uses less energy than other conventional methods. So Spencer was in fact designing his magnetrons, which was what he was an expert in. And these are vacuum tubes that generate microwaves, and the basis of how a radar works. In fact, one time he went into work with the magnetrons and had a chocolate bar in his pocket, which had warmed up and started melting. So what he eventually did with that observation was he created a small metallic box, and directed the radiation into the box, and that was how the first microwave oven was in fact built. So the activities we're going to work through in this cycle this fortnight is looking at the scientific method, doing some more research of our own about peptic ulcers and plant growth and microwaves, and what led to that research, and then doing some more detailed research and investigations about each of those and the scientists that are credited with their discovery. We're also going to be looking at growing bacterial cultures, so what that looks like, and also measuring microwaves by doing an experiment that does involve user microwave. And then, as always, we're going to start practicing our past HSC questions on our Google form, and update our inquiry question log, remembering to go all the way back to the beginning here. And against each of these little descriptor points, we're going to be adding our information to make sure our inquiry log is something we can go back and revise on later. So that concludes cycle 1 of module 5.